section 7.5, more trig equations or advanced trig equations, however you want to say it. Go ahead and zoom on in. So we have section 7.5, more trigonometric equations. And so here we're going to have to just learn a couple new tricks. And so here, let's go ahead and, so remember our steps is to make trig equations look like something that says trig equations. And so here we'll have 1 plus sine of theta minus 2 cosine squared theta equals 0. And so I want to push all the trig equations one side. Let's try to keep it to the same trig equation so I know how to switch a cosine squared to a sine. So let's do that. So we minus 2 times 1 minus sine squared theta equal to 0. Alright, so now let's plug in the 2. So I'll have minus 2 goes in, so that gives me 2 sine squared theta. Here I'll have minus, we can do this right, supposed to be plus sine of theta, and then we minus 2 plus a 1, so we minus 1 equals 0. Just checking myself. Here I can factor this to be 2. Just pretend it's 2x squared plus x minus 1. That's the same thing as 2x minus 1, or in this case 2 sine of theta minus 1. Sine of theta plus 1. Notice here the trick is to write this as x squared, x, and 1. So you get 2x minus 1, x plus 1. That's how it factors, but here we're just using signs. It works the same way. This is equal to 0. We'll go ahead and split these. So here I have sine of theta equals a half, and then sine of theta equals minus 1. Or I guess I skipped the step where I moved this over and divided. Let me not skip that step. Alright, so here we have 2 sine of theta minus 1 is equal to 0, and we have sine of theta plus 1 is equal to 0. So here we'll have sine of theta equals 1/2. Here I'll go ahead and skip one small step there, and we'll have sine of theta here. Theta equals minus 1. Alright, so we want to find all the solutions. So here we've had the half before, so that is the pi over 6 plus 2k pi. And then the other one was 5 pi over 6 plus the 2. Oops, that should be a 6. Plus the 2 k pi. And then here, sine of this, well, this only occurs right here, right? It only occurs at pi or pi. And there is no other thing in one period. So this is the rare case where you only have one solution. And this is just, hold on. Let me make sure. I might have written something down wrong. One second. Alright, so here it starts. Yep. Where is sine equal to negative 1? I starts at 0, it's 1, 0, and then minus 1 here. Sorry. I just wrote down something wrong. But luckily my brain kicked in. And so here it only happens at 3 pi over 2. No other place does it occur. And if we look at our little sine wave, notice here it only occurs once instead of occurring twice, like most other values do, twice or twice. Here it only occurs once at the cusp. And so that is at 3 pi over 2, and then of course to make it all solutions we're going to add 2k pi. Okay? Alright, so here we have a double angle, but we know how to deal with this double angle from our, what was it, 7.3? So this turns into, so let's go ahead and do that. So let's just plug in the double angle. So we have 2 sine of theta cosine theta minus cosine theta equal to 0. Here we can factor out a cosine theta, so I have cosine theta equal to 0. To sine theta minus 1 equal to 0. So we, oops, factor and not skip a step. So cosine theta to sine of theta minus 1. That means either this was 0, this is 0, so either cosine theta equals to 0, or to sine theta minus 1 is equal to 0, which means sine of a positive half. Here, cosine theta equals 0 where? At pi over 2, or pi over 2 and 3 pi over 2. So the answers here are pi over 2 plus 2k pi, 3 pi over 2, which is over here, where cosine equals 0, plus 2k pi. We've seen this 1,002 times. This is pi over 6 plus 2k pi, comma, 5 pi over 6 plus 2k pi. So, I don't know, one of the teaching techniques is something new, or something familiar and something new. This is something new, this is something familiar. I don't know. I just go along with the gag and try to teach. Okay. So here we're just solving. We try to get this to a point where you have something equals 0, something equals 0, and then we just do this. So here we're using more advanced techniques. Here we're using the double angle. Here we're swapping out a sine for cosine for a sine using Pythagorean theorem. All right, so let's just do a couple more of these, which may get interesting. I may not want to do that one. I may want to swap that one. Just to something that's a little easier to do. All right, so here we go. So we have this. So here's something that no one's going to tell you how to do until you learn how to do it yourself. It's like, well, here I have this. I can't get a sine or a cosine on either side equals something that's not multiplied by something. So the trick is, this is just a little tool to have in your bag in case you see it. So you have x plus 1. We're going to square both sides. And by squaring both sides, we solve our problems. This becomes cosine squared theta plus 2 cosine theta. Remember to FOIL this, so first, first, so it'll be cosine squared. Outside, inside, give you the 2 cosine. Last would be plus 1 equals sine of theta squared. Notice sine theta squared is equal to cosine squared theta plus 2 cosine theta plus 1 equals 1 minus cosine squared theta. Oops, that should be theta. Move this over to the other side, so I have 2 cosine theta plus 2 cosine theta, cosine squared theta plus cosine theta equals to 0. This is the same thing as 2 cosine theta cosine plus 1 equal to 0. Here we're just pulling out the 2 cosine theta. So what does this mean? That means either, I guess I'll leave myself some room. That means either 2 cosine theta equals to 0, or just cosine theta equals to 0, and then cosine theta, oops, I've got my theta here, theta plus 1 is equal to 0, so here I have cosine of theta equals 0, and here I'll have cosine of theta equals minus 1. So where is this true? This is true at pi over 2 and 3 pi over 2. So this is true at, so theta here is pi over 2 and 3 pi over 2. If we're in our first one here, this is only true at pi. This is another one where it only happens once. So this is at pi. And so if I want all the solutions, so this is for one period, for all the solutions, we'll just add 2, we'll add plus 2k pi, comma, 3 pi over 2 plus 2k pi plus pi plus 2k pi. Okay, so here's all the solutions for this one. So this one's just a trick. If you see this, just square both sides, and then you'll have sine and cosine squared, and you can convert one of the sines to a cosine or a cosine to a sine. Depends on which one ends up falling out simpler. All right. So let's do this one. So here we have a triple angle. Alright, so this tends to get really nasty, but it ends up being simpler than you think it might be, right? Because here we're just going to say 3 theta, and we're going to say that's equal to phi. And so we're going to solve 2 sine of phi minus 1 is equal to 0, or sine of phi is equal to a half. Well, sine of phi equals a half. Well, then you know that phi is then either pi square root of 6 plus 2k plus 2k phi, and then or 5 pi over 6 plus 2k phi. So that's what if it is for phi, but we don't want phi, we want theta. So how do I deal with this? Well, I just divide everything by 3, right? So theta, and so this is equal to 3 theta, right? So what does theta equal? Well, I just divide it all by 3. So therefore, because remember, phi equals 3 theta, so that means that theta is equal to this over 3 would be pi over 18. Yeah, so 18 plus 2/3 k pi, comma 5 pi over 18 plus 2/3 k pi. And so if we have a triple angle, this ends up being not too terrible because we can just multiply or just divide by 3. So we just solved it simply for like a different angle. So phi, solve it, go what phi can be. Remember that phi is equal to 3 theta, so we just divide out the 3 everywhere. So divide out 3 here and here and here and here, and then we're done. So it ends up being not so terrible. Alright, so I have not given you a tangent one, so let's do a tangent one. So we're going to swap that to tangent. So let's swap that to tangent and go ahead and crash through it. So here, what do we want to do? So here, let's go ahead and solve. We're going to do the same trick. We're going to have phi over 2 is equal to phi. So we're going to solve for square root of 3 tangent. We're swapping this to a tangent so I can show you something different. Phi is minus 1 is equal to 0. That means tangent of phi is equal to 1 square root of 3, or square root of 3 over 3, right? But 1 over square root of 3 is fine. That means phi is equal to pi over 6 plus k pi. But remember that's theta over 2. And so theta, then, we're just going to multiply everything by 2. So pi over 3 plus 2k pi. So I'm just multiplying the 2 here and the 2 here to get the phi. And so if you see these double angles or half angles or whatever, they're actually not all that bad. You just solve for phi instead of theta. And then once you get your answers for phi, you either multiply, as in this case, multiply everything by 2, or you divide. Okay, so that's it. And that's the end of this section. And so this is the end of the trig equations and trig things, and this tends to be one of the rougher sections. So give yourself time to work through it. Keep practicing. You'll get better at them the more you work on them. There's like, you'll start to see things and all this other stuff. They're like puzzles to put together. Some people love this. It's like they're fun little puzzles, and some people just loathe it. It is what it is. Well, good luck. This is the last section when I normally teach this class before the midterm. And so we'll compile it all, and we'll start studying for the midterm. So take care, and good luck.